let's consider the question, what is the area under the curve f of x equals x cubed on the interval from -2 to 1? So, and we'll approach this both ways. Right. So first, let's consider just the graph of x cubed. Right. We know that a cubic roughly looks something like this, and from -2 to 1, this will be 1, and this will be -8. So definitely not to scale, but the question would be with regards to this. So what is this area here? So if we want to consider the area in the curve, thinking about it graphically like this, what this would mean is the opposite of the integral from -2 to 0. And why is that? Because on the interval from -2 to 0, the curve is below the x-axis. Numerically, that will give me a negative value, and area must be positive. So I need this negative out front to counteract that. Plus the integral from 0 to 1 of x cubed dx. And why do I need to do that? Well, because from 0 to 1, the curve is above the x-axis, and that value will be positive. This will give me the total area under the curve on the entire interval. When I integrate x cubed, I get 1/4 x to the 4th on the interval from -2 to 0, plus 1/4 x to the 4th on the interval from 0 to 1. Continuing on, this will be 0 minus 4 plus 1/4 minus 0. 0 minus 4 is -4. The opposite of that would be +4. So 4 plus 1/4, or 17/4 is the area under the curve of x cubed on the interval from -2 to 1. So that's thinking about it as the function lies and just making the necessary adjustments for each interval. Now, we could think about this in terms of the absolute value. Right? So if I wanted to just integrate the whole thing from -2 to 1 of the absolute value of f of x dx, graphically what that would mean is that I'm considering the function in this method. So this would be 8 here, and this would be 1 down here. And so the graph's going to look roughly something like this. Probably a lot more accurate picture in this case. And because I'm looking at the absolute value of the function, everything is above the x-axis. So everything is positive. And the question becomes, well, then how do I integrate this? Well, I still have to recognize that there are two pieces to this. That the function is still, so on the interval from -2 to 0, the function would be negative x cubed. And on the interval from 0 to 1, the function would be positive x cubed. Right? These would be the pieces inside the absolute value. So I still would have to, if I'm doing it by hand, integrate two different functions. I'm going to integrate from negative 2 to 0, negative x cubed dx, plus the integral from 0 to 1 of x cubed dx. And when I do this, I would still end up with the exact same value as the previous 17/4. Now, I would submit, though, that if you were able to use your calculator to integrate, then this method would be simpler. And we'll show how you could do this in your calculator in a moment.